Hello, good evening. Has the presenter joined from Watered India, please? Amita Pataria has joined. Okay, fine.
I will ask my colleague to join.
Okay, fine. Okay, good afternoon to all once again. Actually, our advisor sir is in a meeting. In fact, the training is going on. So I'm requesting him to join. Let me wait for 2-3 minutes only, if he can join. Okay. And then within 2-3 minutes, we shall start the session. Just as an advisor sir is busy in a training program, so just waiting for him 2-3 minutes maybe. I am not sure even he can join or not. So we shall be waiting for another 2 to 3 minutes to see if we can make our advisor sir join the system.
Solid.
Good evening once again. Sorry, Sir is still busy on the valedictory training. So let us start as it is already 4. Hello, all please put your microphone off, please. All the participants are requested to put off their microphone. So, shall we start? Ms. Amita, can you
Yes,
start?
yes, we can start.
Okay,
Yes, sir.
okay.
Yes, sir.
Okay. Thank you very much. We're going to start. So, as you know that Shamaprasad Mukherjee National Institute of Water and Sanitation is a premier institute of Government of India and Jal Jeevan Ministry, Jal Shakti Ministry, and it is a very new institution, but we are trying to give a shape to this institution to the international standard. And in 1 hour of our program, we are trying to hold some webinar to disseminate the knowledge of different stakeholders across the which different stakeholders across the country. And today there is a very interesting subject. We have invited people from Water Aid to give a presentation. In today's webinar, Mr. Purnachandra Mohanty, accompanied by Ms. Amita Pacharia from Water Aid India, will present a very important topic: challenges in grey water management, issues is maintenance of decentralized soak pits, and ways to overcome them. Very interesting topic indeed, and very current also, very burning topic. Mr. Purnachandra Mohanty is a technical specialist in sanitation at Water Aid India. With over 2 decades of expertise, he excels in WAS, disaster risk management, and water resource management. Mr. Mohanty is a prolific author on topics like groundwater management and disability inclusive WAS. Committed to transforming marginalized communities, he champions access to clean water and sanitation as fundamental rights through innovative programs and policy modifications. Ms. Amita Pacharia is an urban strategist with 7 years of experience, holding a master's in urban and regional planning. Specializing in urban sanitation, she has contributed to non-sewage sanitation capacity building program in India. As a sanitation specialist at WaterAid India, Amita focuses on diverse initiatives like accessible toilets, Swachha Anganwadis, rural FSM policy, and community-led water and grey water management. In today's presentation, they will discuss about critical challenges faced by grey water management, intensified by increasing water supply and population growth. Though decentralized soak pits, leach pit, and other on-site treatment systems are common solutions, their maintenance poses significant challenges. Their effectiveness is often hindered by various factors such as soil permeability, water table levels, and improper design or installation. In this presentation, they will address these challenges and will throw light on ongoing efforts to ensure the effective operation and maintenance of these systems, ensuring long-term environmental protection and water security in rural and urban areas. And in today's session, we are keeping 1 hour for the presenter. And during the presentation, we request all the participants to put their microphone off and not to interfere their presentation. And after the presentation is completed, we shall keep the forum open for all for interaction for question and answer session. And in the meantime, if you have any question, any feedback, you can use our Google form that you'll find in the chat box. In the chat box, we'll upload one Google form. There you can give your feedback, your comment, and your questions also. And this program, it is my pleasure to inform you that this program is also live streamed in YouTube channel, our YouTube channel also. And now it is my pleasure to present before you the Mr. Apurna Chandra Mohanty and Ms. Amita Pachuria from WaterAid India with the topic, a very important topic on clear water management. Thank you very much.
Thank you so much, sir, for the head start, and thank you for introducing us. Good afternoon, everyone. I'm Amita, as just sir introduced me. I'm Amita Patria, sanitation specialist from WaterAid India. And along with me, Chandra Mohanty, my colleague. So we'll be presenting in front of you today regarding a pressing issue of grey water management systems in rural areas by addressing challenges of decentralized soak pits and leach pits. So our presentation would look like this. So first we'll talk about some concepts like liquid waste components,
Amita,
grey water.
Amita, your presentation is
Yes.
not visible in the screen.
It's not visible. It's
No.
not visible.
No. Can you share again?
Screen is bad.
Let me share again. Let
Screen
me
is
share
bad.
again. Yes.
Please.
Is it visible now?
Not yet.
No, not visible.
Okay. I'll try another way. Is it visible now?
No, still rolling. Blank. Screen is blank.
No. Screen is,
In other way, if you can send it to SPM Nivas and if it can be projected from there, we can carry forward the presentations.
it is already with us, so you can do that, but still you can please try a little bit.
Yes,
Then
I'm.
we can,
Yes,
we
I'm.
can do that.
Yes, I'm trying. From my end, it looks like it's been shared, but I think it's not up on the screen.
Screen share. So, shall we share the screen, please? Shall we present it?
I'm sharing
I
the
think
update. Sharing the updated.
we have updated a little bit. I think Abhita, if you can send the updated version as well to SPM Nivas, then
There's no problem.
Because it's like it's not loading.
In the beginning of the session, it was visible. In the beginning of the session, it was visible. When you uploaded first, it was visible. But right now, it is not visible.
can we request all others please mute your mic? It is creating noise in background. Please.
I think the కానీ అదే చెప్పేది అది క్లారిటీ కాదు నెక్స్ట్ పోస్ట్ ఈ నెక్స్ట్ పోస్ట్ ఈ ప్రజెంట్
I think Amita, it is better you can send the updated PPT to SPM Nivas. You can forward by email. Then it can be presented from that end, and we can continue.
ਇਹ ਪਤਾ ਨਹੀਂ ਕਿੱਥੋਂ ਕਿੱਥੋਂ ਦੇ ਆਈ ਆਲ ਓਵਰ ਇੰਡੀਆ ਦੀ ਆ ਤਾਂ ਮੈਨੂੰ ਲੱਗਦਾ ਸੁਣਦਾ ਤਾਂ ਹੈ ਨਹੀਂ ਯਾਰ ਕੁਝ
I have shared the presentation with you if you want to project. Meanwhile, I'll try. Is it visible now?
Yes, it is visible now.
Now it is visible.
You
Yes.
I'm
You
so
can
sorry.
you
I'm
can
so
bring
sorry
it to
for
the
you.
bring
Yes.
it to the
Is it-
presentation mode.
Yes, is that fine now?
Yeah, fine.
Yes, it is
Okay,
fine.
I think
So
But
let's
it's a request
start.
to all to put their microphone off, please. While presenting, please put off all the microphones, please.
Thank you all for your patience. Yes, so I was saying that today we are going to discuss on the pressing issue of grey water management system in rural India, and while doing that, we'll be addressing challenges of decentralized soak pits and leach pits. So our focus will be today will be on soak pits and leach pits. Our presentation would look like this. First, we'll talk about liquid waste components, then grey water quantification through an example, why grey water management is important,
it
what
is
is the
not
grey
rolling.
water management.
Not rolling.
Psychology, can you share the presentation, please? There is some, I think, network problem from my end. Possibly.
Okay. Yeah, that you can do. Shall we upload the earlier presentation what you sent to us?
I have shared the updated one.
Okay, through mail, na?
Yes.
Okay. Let me try. Okay. Mail.
Have you received the updated email?
Amita, you can try again.
No, I am here. No. No, we are not receiving any PPT right now.
I've just sent it.
It will take, maybe it is taking time because of some network errors.
Amita, you can try again sharing the screen.
Yes, Purna. Please check Saikya-ji. I think you might have received the file. It is shown being sent from my side in my system.
It has not reached me right now. Till now, it has not reached me. So you placed the earlier email.
Now the mail, she has shared a mail.
Just now at 4:17, I mailed you.
Wait. It has came, just came. Please wait.
Okay. Samita, you can you can stop sharing.
Okay.
Yes, we have received a PPT. Wait, we have received a PPT. Yes, it has reached us.
We are really sorry that we are being little late uploading the PPT, and that is why we are late in describing this. I think Amita, you can start now. Saikaji,
Yes,
if you can put it into the presentation mode. Yeah. Thank you. Thank you for the patience. Let us continue.
second slide, please.
Is it okay? Is it all right now?
Yeah, it
second
is,
slide.
but you can roll the second slide.
Oh,
Okay, right. So next we'll talk about water management scenario in rural India. Then technology option matrix. What are the various technology options at what levels? Then common interventions. Details about soak pit, leach pit, challenges in decentralized soak pits and leach pits, and then possible interventions and your insights. Next, please. So in India, only 28% of the actual quantity of used water generated is treated. So 72% of used water, which is left untreated, is disposed of in rivers, lakes, groundwater. Niti Aayog, August 2022 says this. Next. So here we look at the liquid waste components. So basically liquid waste or maybe the liquid types of liquid waste are grey water, black, yellow and commercial from commercial establishments. And we'll be focusing on grey component, which is ideally not contaminated with fecal or urinal matter. So this basically comes from kitchen and bathroom of households. So kitchen water, bathroom water, cloth washing, and utensil washing. Next. So here we want to look at the grey water quantification. So let's see that during 2024, which is currently, we have 55 LPCD water supply in villages, and a village, assuming a village with 1,000 people of population, it would be so just for the basic thumb rule. 80% of fresh water received at any household is given out as grey water. So in this case, which is during 2024, 55,000 liters of fresh water is received in a village, and 45,000 liters of grey water is discharged. Similarly, we assume during 2034, with implementation of JJM and also decadal population growth, as well as higher demand of water supply, if we assume that the water supply rises up to be 70 LPCD, and a village has a population of 1,200 people, so the fresh water supply also increases to 66,000 liters, and thereby grey water also increases. So it is important to understand that with time the grey water generation is increasing day by day. Next, please. So, firstly, I would want to quote that managing liquid waste is crucial for rural sanitation. Population growth and development have reduced freshwater availability and polluted water bodies due to unmanaged wastewater. A holistic approach to wastewater management is needed, turning treated wastewater into a water source. In rural India, grey water and black water are key concerns. Historically, grey water was minimal and manageable at the household level. However, lifestyle changes and increased household activities like bathing, washing inside the households have boosted grey water generation. The Jal Jeevan mission will further increase grey water generation by providing water supply connections to every village and household. So improper grey water disposal pollutes water bodies, harms ecosystems, and create health hazards. So here we, in on the slide, we look at the negative impact of improper grey water management and the positive impact of proper grey water management. So let's look at the negative impact. So probably would be unpleasant and dirty surroundings. There will be health implications of waterborne diseases, pollution of water bodies, and loss of natural resources. If we look at the positive impact of proper grey water management, there will be improved public health, groundwater conservation, increase in green cover, and contribution to nutritional status. Next, please. Next slide, please. Yeah. So here in this picture, we are looking at a hand pump with a dilapidated platform, and there is water logging there, and unmanaged situation of grey water is seen, and we see that how the environment.
Can we request to
చాలే
mute, please? Anantapur MIS, please mute, please. There is a noise coming out of your mouth. Yeah.
Yes. So here we see a dilapidated situation and condition of, and problems with the contamination of maybe the groundwater or maybe the environmental problem. So looking at this picture, we see that why should we manage grey water? Why it is important? Next slide, please. So this is an animation. So please click 2-3 times. So right now we are looking at grey water management in rural context. So ideally, what happens? So in the picture we see there is a water source. It could be well, it could be tube well, it could be tap connection or hand pump. So here we see a hand pump. So water is collected from source. Next. So here in the household, these activities happen like laundry, bathing, showering, and what kitchen activities. Next. And this water is discharged into either natural water bodies or the environment, polluting the environment. Next. So in these pictures, we see that because of this situation, what happens to the environment and surroundings when grey water management in rural areas is not managed properly. Next. So next. So here we see that there is an image where a man is drawing water from a hand pump, and there is a magic pit just beside the hand pump, and the water is collected. Again, the same activities happen in a household. Next. Please press 2-3 times. Yes. So the water is released, and then we advise that there is treatment. So we have to decide whether we need to recharge. So first preference should be the recharge of the aquifer or the groundwater, and then the reuse. So if we are recharging the aquifer directly, the minimum treatment should take place. And if the reuse is we opt for reuse, then the treatment of grey water should be as such that BOD, COD, and other parameters levels are reached as per CPCB norms. Next. So minimum treatment, what basically it consists of. So these are treatment modules of minimum treatment that I'm talking about. The first one is separation of solid waste through screening. Next is removal of settleable solid settler. Then reducing BOD, COD levels through anaerobic or aerobic process. And then removal of nutrients or pathogens by PJ for polishing pond. Next. So now we are talking about technology options matrix here, and grey water management can be taken care at 3 levels. One is decentralized, which is mostly the household level management, where we see common interventions as kitchen garden, soap pit, leach pit. At semi-centralized level, that is community level management, there are two types. One is group of houses collectively we manage, and at public water points. So here we see a lot of times community plantation, leach pit, deworts. And at centralized level, which is at village level, we generally see waste stabilization ponds, deworts, FBR. Next. So here today we are focusing on decentralized systems. So here under the Sujalam 1.0 initiated in August 2021 and 1.0 and 2.0 campaign, more than 2.5 million soak pits were built at the household and community levels across the country. Next. And there's another fact that as per JJM, it has been decided that a soak pit or a leach pit should be constructed attached to every functional household tap connection or community water points in rural areas to avoid water and vector-borne diseases. Next. What are the common interventions? Common interventions at household level are soak pit, leach pit, magic pit, kitchen garden. And at community level, we see leach pit, deworts, or WSP. Next.
We are unable to listen you, please.
Am I not audible?
No, audible.
Yeah.
Ma'am, you are audible. You are able to ask at least.
Right. So
if somebody is not hearing, then that is a local problem.
The previous slide, please. Yes. So let's delve more deeper into what soak pit and leach pit systems are. A soak pit is a dugout pit that is filled with graded stones and gravel. The stone increase the. Please put your mics on. DPMU.
इसके बगल में सोच पिट होगा वही बगल में.
Please put your mics off. So, a soak pit is a dugout pit that is filled with graded stones and gravels. The stones increase the surface area over which biological and chemical actions take place. So installation of soak pits is also recommended near hand pumps, stand ports at community level as a measure for management of the grey water generated. So in the picture you see that there is a hand pump and then a soak pit is installed just connected to it. Next. So now let's look at the prerequisites of any soak pit. So if we see what kind of soil type would support a soak pit. So a good absorptive properties soil would be very crucial for this. So high permeability soil like sand is efficient in comparison to low permeability soil, which is black cotton soil, clay soil, or rocky terrain. And for site selection, size of pit is based on the grey water generated, which is directly proportional to the number of people who are generating the grey water. Then no storm water in soak pit should enter. And also low-lying areas. In low-lying areas, it is mostly unsuccessful, the soak pits. It is not advisable in high water table areas. And it is also not advisable very near to the water sources. So here you see an image that a graphic that shows how a soak pit section looks like. And in case of household level interventions, the bottom level of the pit should be at least 1 meter above the water table. Next. This is a community soak pit. It is a little. The concept is same, but it is little different in terms of the dimensions. Otherwise, it's the same. Next. So, what are the advantages and limitations of soak pit? Advantages would be low cost and easy to construct. It can be built and repaired with locally available materials. O&M costs are low and borne by individual households. Limitations would be soak pits handle lower volumes as compared to leach pits. Unlike leach pits, soak pits cannot function in semi-permeable soils. Chances of clogging due to silt in the influent are higher than in leach pits and magic pits. And it is they are not much suitable for areas with high water table due to contamination risk. Next. Let's talk about leach pit now. A leach pit is either constructed in a honeycomb brick masonry with cavities in alternate layers, or by stacking concrete rings having 5 to 6 holes in each ring. And the function is very similar to what soak pit does. Here in the picture, you see a soak pit which is attached to an FHTC. Next. So for leach pit, the prerequisites would be permeable and semi-permeable soils. And in case of clayey soils, 300 mm of sand envelope around the pit is constructed. Then for site selections, the size of pit depends on the specific number of people. Again, stormwater should not enter the leach pit. Low-lying areas should be avoided. Not advisable in high water table areas and near water sources due to risk of contamination. Next. Here is a axonometric view of a leach pit. Here, so while constructing the leach pit, the portion above the ground, which you can see here, should be covered, always covered. Next. So what are the advantages of leach pits? So capable of handling higher volumes compared to soak pits and magic pits, can be constructed in semi-permeable soils with nominal modifications, and chances of clogging are very low. And limitations, since a leach pit is a permanent construction, the site needs to be selected appropriately. Otherwise, it may result in problems like flooding of the leach pit, etc. Construction of this technology is costly compared to other on-site technologies. Skilled labor is required for the development of the honeycomb lining, and it is not suitable for areas with a high water table. Next. So this is leach pit calculation, the size of the leach pit basically. So if we assume that a household has 5 members and each person produces 40 liters of grey water, then that household would produce 200 liters of grey water. And in case of a community leach pit, so one leach pit is for 10 houses. So number of houses is 10, so thereby grey water produced each day by 10 number of houses is 2000 liters. So as please previous slide please. Previous slide please. Please go back.
Go back.
Yes. The appropriate volume of the leach pit must be doubled as per standard. So 1000 liter grey water is produced, so we'll assume that 4000 liters of grey water has to be treated, and which counts to be 4 cubic meter. Next slide. So we assume that each household has 5 members. So in that case, 4 cubic meter of volume of leach pit is calculated. As per standard, diameter of a community leach pit should be 2 meter and standard effective height should be or depth should be 1.4 meters. So as per the calculation, the size or the volume of the leach pit would be 4.4 cubic meter. Next. So let's talk about the soak pit and leach pit challenges. So here in the pictures, we see that the first picture shows that there is a broken platform just below the hand pump. And then there is an open leach pit with a lid though, but there is a possibility of there is a possibility of storm water entering it, a possibility of contamination and dirty surroundings. But let's look at the picture at the right. So it shows that a well-managed grey water system leads to cleaner environment, and the contamination risks are negligible. Next. Please press 2-3 times. There is one. Yes. So first situation would be high water table, water logging in surrounding of soak pits. So if there is high water table area or water logging permanent or temporary happens, or there is flood prone area. So here what happens if soak pit is constructed, overflow from the soak pit or leach pit in the surrounding results into water logging. So first figure shows that if a soak pit is constructed in a high water table, there is overflow and then there is contamination of the environment. The second figure shows that there is a soak pit in a high water table area and it contaminates the groundwater. If water directly discharges from soak pit or leach pit into drain, water body or environment, then it contaminates the same. Next. Okay. So here in this is the case of rocky strata and hilly terrain. In hilly area, soak on higher contour flows into lower contours, causing soil erosion. So here you see a hilly slope, where there in the catchment area, the lower part, catchment area, there is an open well, and if there are if there is a settlement on the higher ground, there will be septic tanks which might leak into the open well, which might contaminate the water source. Next. Next. Next is soil permeability. So in this case, if it is sandy soil, then it is efficiently soak pit and leach pit would work. And if there is a water source within 10-meter radius of the soak pit, then it will get contaminated. And if there is semi-permeable or impermeable soil, then grey water will not leach in such condition. Therefore, it will overflow into the environment. Next. The last one is the faulty technical design. So there can be many faults in the technical design of a soak pit and leach pit. To list a few would be no honeycomb design in the leach pit. Maybe both RCC ring or brickwork, it is improperly constructed. If there is no soak pit cover, then there is a problem that stormwater can enter into, and there can be breeding of mosquitoes, and that such environmental issues and health problem can occur. If the pipe is ending at the wall surface and not reaching the center of the pit, then it will hamper the side wall of the soak pit. Then shape and size are not as per design consideration. If the mason is not properly trained and he has not calculated the size of the soak pit well, then there will be problem with the shape and size of the leach pit, and therefore there will be problem in the functioning of the soak pit. Then improper operation and maintenance. There can be improper operation and maintenance. Like for an example, the filter media in a soak pit, if it is not changed, if it is not revamped, then there is a problem. Now I will hand over to Purna.
Yeah. Thank you. I again request all the members, all the esteemed members, please unmute yourself. There is a noise, there is sound coming from Mr. Saurabh Kumar, from DPO, some other area. If you can please mute yourself, Mr. Saurabh Kumar. If you can mute yourself.
Subhash Kumarji, please mute yourself.
It is a request from the host also. All the participants, please put your microphone off, please. Please.
DPMO RPG. Yeah. So far, I will just give a flashback, then we can go ahead. So far, we have discussed what are the how we can construct the soak pit or leach pit. We have taken up massively the soak pit, leach pit implementation through our programs, through different programs in different areas, starting from the household level to the community level, maybe nearer to the hand pump, maybe nearer to the cluster of houses, maybe to other areas also. If you can, if you are looking into those things, then we are finding in the rural area that at maximum places, the leach pit, soak pit, magic pits have been constructed. There are other technologies, but we can take up other technologies in other sessions. Right now, we are discussing on the challenges about the leach pit, soak pit. As Amita has shared, the challenges she had shared as according to the waterlogging. If the area is waterlogging, if the area is having high water table, means the water table may be within the limit of 1.5 meter or around 5 feet, 6 feet, or more than that, in the below the ground level, and the area is disaster prone, and the area is disaster prone. And again, if the constraints are like if hilly terrain, then the problem may be from the leach pit, the water leaching down and may also contaminate to the drinking water source or other sources, or the water leaching down may also further in the slopy terrain, it may also create soil erosion. So these are all challenges that we are facing now. If we have constructed soak pit, leach pit, we have constructed it for the treatment of used water or wastewater. But right now, what we are seeing after the construction of soak pit, leach pit, still the area is having the same. The problem is having the same, and we are finding again the untreated water to be treated in soak pit, leach pit, but at the output level, again it is becoming the untreated water without the treated water. So we have thought of, as Amita has shared about the challenges, we have thought of to share a few things that we are thinking that we can do as a solution towards it. So we have divided the option into two. One is if already there is existing the soak pit, leach pit in the field, how we can retrofit it into a further way that we can make it a safer practice of treatment of grey water management. If it is not taken up in any area, then we can take up through new technology options, as it has already been said how we should have to take precautions while we are going for least speed soak pit designs, and how we can put least speed soak pit some specific way in the ground so that it will be effectively functional, or otherwise we can take some other actions. So considering the first option, in case of existing soak pit, leach pit which are there in the high water table or water logging area, so we have taken few options. This is example that we are sharing. Further, we can discuss on this. So this is a this is a kind of thinking that we are sharing with the audience, that they can think about this, or they also can suggest if they have some other innovative idea, or if they are agreeing to this particular options. So in case of option one, wherever the water table waterlogging area is, if the groundwater table is within 1 to 1.5 meter and there is a impermeable soil. So if the soil is not permeable or semi-permeable, then there the soak pit, leach pit, if you are constructing the soak pit, leach pit, then it will not recharge to the ground, or if it is recharging to the ground, reaching to the shallow aquifer, then it may contaminate the aquifer there. So we are suggesting the solution as the bottom of the leach pit soak pit should be lined, and after that the leach pit soak pit can act as a settle tank or settler, and after that can we think about a PGF, planted gravel filter, or rebed following to the leach pit soak pit, so that water treatment can happen and treated water can be reused properly for plantation purpose, for agriculture purpose, or it can be allowed to the village pond or some village water body, so that safely it can be uh, treated. Then in option 2, in the same category, can you also think about creating an envelope surrounding the leach pit soak pit, and if we can provide the plantation within it. Plantation can be the banana plantation or like the banana plantation. So the broadleaf plant, so that this can easily take the nutrient part, and further it can act as a transpiration process. Further, water can be evaporated to the surrounding, and transpiration will happen due to the presence of the plant, so that if there is a less chances that water will go down, will infiltrate into the groundwater, into the soil below, it can take a upward movement, nutrition can be taken by the plant, and further evapotranspiration can be happened. So second option can be a soak pit having a surrounding envelope with aggregate or with sand or with or on a top soil, and if we can take off plantation. Option 3 can be if there is a least feet and there is overflow happening. Still, if there is a chance that it is the water is permeable and water is missing, then can we connect the least feet to another least feet to another least feet? If we are connecting it on a series of least feet, but keeping a distance between two consecutive least feet save, we can also amplify the recharge to the ground. So if we are going for new construction, then we should consider what is the local situation demands, whether we can use the water for recharge or reuse. If water is, if the if the soil condition, local condition is right for recharge, then we can recharge it. Or if we will have to reuse it, then we'll have to go for different other treatments as we have suggested, or we can take up some other new technology like DWAT or some other technologies. So this is a kind of solution we have thought about: water table and waterlogging area or flood prone area. Can we go to the next slide, please? We will also show you the diagrams. So following to the text, let us go through the text, then we can also discuss on the diagrams. Can you go to the next slide, please? Yeah, I think yeah. So now let us discuss on the area having rocky strata or hilly terrain. As we have discussed, in case of rocky strata, hilly terrain, if we are constructing a soak pit at a higher altitude, there is a chance that soak pit or leach pit may also contaminate to the drinking water source if it is at the lower altitude. And in case if there is a slopy ground, then also leaching water from the leach pit or soak pit may create a slushy soil, and that also helps in erosion. So in that way, we should have to go for plantation and some other things. So the option can be the bottom of the leach pit or soak pit can be lined to make it a kind of containment or settler first, and following to that, the water from the leach pit soak pit should in the next phase go past the leach bed or soak pit. Then the second thing is, after that it can also go to the treated water can be allowed to recharge to the village pond if there is a water body, or else we can also pass through the stormwater drain that is existing in the hilly terrain, so that it will not further create a contamination to at the down level. And in case of option 2, we can allow the excess water from the soak pit leach pit to flow into the plants directly. Like these plants, maybe kitchen garden, maybe banana plants or similar, that we can avoid. By that, we can avoid soil erosion in that case. In case of new option, it remains safe. We'll have to consider whether we'll have to reuse the water or recharge the water. We also will have to consider the local condition, and accordingly we can put for the treatment measures. Next, please. Next slide, please. Yeah. The third one, let us discuss about if the case is soil impermeable or permeable, then we will find there may be the soil having permeable soil or soil having impermeable or semi-permeable soil. In case of permeable soil, it is fine that if we are constructing a soak pit or leach pit that is appropriate as per the terrain, it can recharge down to the ground level. But one constraint is that if there is a drinking water source nearby within the 10-meter radius from the leach pit soak pit, then there is a chance that the water flowing from the leach pit may contaminate to the drinking water source. In that case, we will have to restrict any drinking water source not to be constructed within the 10-meter radius of the leach pit soak pit. If it is constructed, then we will have to line the side wall so that the leaching may not happen directly to the open well or to the drinking water source or to similar structures. So, or we can create a barrier. We can construct a barrier underneath the soil, so that leaching we can avoid direct leaching to the soil. By that we can protect the drinking water source. Otherwise, we can use that particular water source for other drinking domestic purposes, and we can safely construct a new drinking water source which is at a distance more than 10 meters uh, from the leach pit or soak pit. If the soil is impermeable, then we can create a sand envelope around this, or the envelope can be created by putting aggregates, the chips or aggregate or some similar materials, gravels or similar materials. Because the soil is impermeable, so the water will not flow uh, very frequently, uh, infiltrating down to the earth. Water will make a upward movement, so in that case, we also can go for creating plantation, and through the evapotranspiration process, as I have already told, we can make the plantation on the aggregate surface, so the plants can take care of the nutrients and transpiration can happen and evaporation can happen. That also provide a solution to this. In case of a new thing, then we can go for other DWAT and other specific models, or we can go for a modified leach pit model if we are going to construct the leach pit or soak pit in the same region. Next, please. Yeah. So this let us whatever discuss, let us see it in example. This is a lease pit. We are going to modify it. It may be at household level, maybe at community level. Mostly this type of lease pit and we are considering at community level. So there we can consider the lease pit, the surrounding envelope to be filled with permeable soil or sand. And can you can you put on, can we go next next? Sir, you are creating disturbance. You are talking and putting mic on. DPMU RPG. Sir, you are discussing and putting mic on. DPMU RPG.
Yes, DPMU RCB, please put your microphone off, please. All the participants are once again requested, put their microphone off.
Yeah. Sir, can we go next, please? Yeah, this is a modified lease pit. If we have already a lease pit constructed, we can create a surrounding envelope, digging the soil, taking the impermeable soil out. We can put the sand or the permeable soil within the strata, and we can go for plantation, banana plants surrounding the soil. Sir, can we go next, so that we can see? Yeah, there are. Yeah, these are all banana plants. We have just made an animation. So accordingly, we can go for treating the modified the lease pit to a modified form. Next, please. So this is a kind of further another attempt we have made. This is a lease pit constructed. So adjacent to the lease pit, the water from the lease pit is flowing to the reed bed, and in the reed bed water flows on a horizontal way, and there water can be the plants should be there in the reed bed, so that plant can be taken nutrient and water can be filtered, and the treated water can reach to the nearby, or to the it can be treated water can be used for agricultural purposes. Yeah, next please, sir. So already we have discussed all these models. I am just showing it in a diagrammic way. This is a already existing leach pit. So existing leach pit, if there is a overflow, that overflow can come to the reed bed. If we are allowing the water to the reed bed, the treatment happens there. So BOD, COD rate is reduced, pathogens are arrested. Now the treated water can reach to the village pond. So there it will not contaminate further to the water body, existing water body. It also can be used for plantation purposes. Next, please, sir. So this is a kind of envelope. If there is a permeable, the soil is semi-permeable, means permeability is there. The soil is having permeability factor, but it is not up to the mark. Then in that case, if you are only constructing the sand envelope or the sand filling above the soils, above the soil strata, and raising the leach speed. In that case also, we can increase the time of filtration by providing this sand envelope, and that way the water can also infiltrate to the side soil strata and to the bottom strata. It will take some more time, but it will infiltrate. Yeah, this we know, we have already used to, but we have put this as we are just sharing this as one of the options that we can go for retrofitting. Next, sir. Yeah. Here we are describing if there is a already the leach fit is there, then we can do retrofitting by providing a sand envelope, and we can do the plantation. As I have already told, evapotranspiration process. So this is an example. In the right side, you can see a photograph. That is an example which is taken up in West Bengal. So in that case, the water leaching from the households can be managed in this way. So that is an example that we are putting in. Next, please, sir. Yeah, we were already talking about. This is the last slide. We are already talking about the least bit in a series, but we will have to consider the distance between the horizontal distance between the least bit, because if we are considering the height of the least bit as 1 meter, so then the horizontal distance should be 1 meter at least, so that the leaching can happen properly in first least bit, in second least bit, and continuously in the third least bit. So in that way, we can enhance the leaching of the water to a greater soil strata, bigger soil strata. That way, if the water is coming to the leach pit and creating waterlogging surrounding a leach pit, then that can be avoided by constructing a series of leach pit. We also can take up, if we want, we also can take up plants on the soil, so that the topsoil can be means kitchen garden or some similar plants on the soil, so that also can be possible. So we are trying to make some thoughts, some insights that we can go for retrofitting the leach pit, soak pit that we have already constructed. But in same way, we also should have to consider the safe construction practices. If there is a faulty design, if there is a repairing required for any construction, already existing construction, then we should go for that. If we are taking up new, we should go for a new safe construction according to the volume of water. We should have to design the leach pit as it has already been said, and also we have to consider the operation maintenance. In case of a soak pit, if the soaking material is there inside, we should have to clean periodically the soaking material. In case of leach pit, we should have to also take away the sludge deposited or solid deposited within the leach pit periodically, so that it can be effectively functional. And we also, in case of plantation, we also have to periodically check the plant and replant in such a way so that the evapotranspiration process can also be effective. These are all thoughts that we have shared, but we want to listen from you, sirs, madams, everybody, that whether these thoughts are appropriate, or you have any new innovative thoughts, or you are thinking in some other way. That let us also open the floor for further discussion on it. Thank you. Sir, can we go next to the slide? Yeah, I think we can roll the last few slides, and one by one slide, we can continue the discussion. If any member from the audience want to share their thoughts, or if they have any agreement or disagreement or any comments on all those options, solutions, options, or challenges that
Yes,
we have already.
yes, it's a good presentation, very good presentation indeed. There are lots of questions with setbacks. There are lots of questions. I think now we can start the introduction session at least. So let us stop the
Yes, sir.
slideshow, and
Yeah.
we will discuss them better. Okay.
Sir.
नमस्कार सर, मैं नीता बोली थी बैतूल मध्य प्रदेश से। सर मेरी आवाज सुन पा रहे हैं?
अच्छा, मैं पहले एक बात बोल दूं। पहले anybody who wants to put a question, please raise your hand electronically so that we can give priority. Yes, Dr. Nita Pal, you can speak.
जी सर। सर थोड़ा मुझे ये समझना है कि सोक पीट और मैजिक पीट दोनों में क्या डिफरेंस है, और हम साइट सिलेक्शन में कहाँ मैजिक पीट ले सकते हैं और कहाँ सोक पीट ले सकते हैं?
Magic Pit is a modified version of lease pit. We can say Magic Pit is a modified version of lease pit. If we are going for constructing a Magic Pit, we should have to put a cylinder kind of structure, a bucket or cylinder kind of structure, or a containment surrounding the recharge area, so that if there is any solid or if there is any sludge coming through the grey water, that can be collected in the containment, and further the water from the containment can flow to the envelope created through aggregates or created through sand envelope, so that through aggregates especially, so that water from the containment can come to the aggregate site, and it will further leaching to the soil strata. In case of a soak pit, we can consider the soil strata underneath is a kind of is having stability, so that it will not eroded into the hole. It will not getting hampered, or it will not getting affected due to the deposit of water within the hole. And the further the material soaking material will help in the leaching process, in the recharging process to the level. That is a soak pit. We can say in a short way, we can say soak pit is a we can take up soak pit at household level, or at small population level, or at level where grey water is having some in a less quantity. But in case of grey water is coming in a comparatively higher quantity, higher volume, then we should have to take up magic pit instead of soak pit. And also there is a chance that we can convert the existing leach pit into a magic pit to enhance its function, to enhance the recharging to the soil. And we have said another option, we also can take up on the top of the aggregate, we also can take up plantations like banana or canna plant or similar plant, so that nutrients can be taken by the plant and evapotranspiration process can happen. So these are all three ways we can do modification, we can differentiate, and we can use. If there is more volume, we should have to go for the magic pit, more volume of water that is releasing. I think I made some highlight, and any other member from the audience, if they also want to share something, they can say.
Yes, there Harish Patel ji, आप कुछ पूछना चाहेंगे? Mr. Harish Patel ji, are you there?
Yes, sir. Yes,
Okay.
sir.
You can ask.
Thank you so much. ये ग्रे वाटर के ऊपर जो भी डिजाइनिंग कॉन्सेप्ट का क्लैरिटी देने के लिए वाटर एड के जो भी मेंबर हैं उनको मैं थैंक यू कहता हूँ। जो चैलेंजेस मैं फेस कर रहा हूँ और मैंने जो विलेज लेवल पे मैंने देखा है, उसमें जो सबसे बड़ा है, एक है इंफ्रास्ट्रक्चर लेवल डिजाइनिंग चैलेंजेस, कि जहां पे पर्टिकुलर डिजाइन सजेस्ट किया है जो गाइडलाइंस के थ्रू, वैसा सॉकपीट ना बन के कुछ अलग तरीके के बनते हैं। ठीक है, तो वो एक चैलेंज है जिसकी वजह से उसका जो एज है, उसका जो हमने टाइमलाइन तय किया है उसके पहले भर जाते हैं और वहां पे पानी का ओवरफ्लो होके वहां पे स्प्लिटिंग हो। नंबर 2, जो हमने ऑब्जर्व किया है कि अर्बन और रूरल का पूरा डिफरेंस जो है उसमें रूरल लेवल पे कहीं पे भी मतलब पाइपलाइन नहीं है जहां पे क्यूमुलेटिव एक जगह पे पानी आएगा और वहां पे हम ट्रीटमेंट करेंगे, इंडिविजुअल लेवल पे चलता है। जो फंडिंग की बात है, जब इंडिविजुअल सॉफ्ट पिट बनाना है तो वहां पे एसबीएम का कोई डायरेक्टली इंडिविजुअल रोल नहीं है, वहां पे कन्वर्जेंस आता है मनरेगा या कोई दूसरे फंड्स का। वहां पे चैलेंज आता है तो इंडिविजुअल लोग नहीं बना पा रहे हैं। एंड जब कम्युनिटी लेवल का बनता है एसबीएम जी के थ्रू, तो वहां पे जो कनेक्शन है हमने ज्यादातर फेस किया है कि गांव लेवल पे बाथरूम होता है और उसके अलावा एक मतलब एक चौकड़ी टाइप का होता है घर के बाहर जहां पे लोग कपड़े धोते हैं। तो ज्यादातर गांव की प्रैक्टिस में हमने बाथरूम के अंदर कपड़े धोने का सिस्टम नहीं देखा है। तो बाहर में जो चौकड़ी होता है वहां पे उन्होंने जो रेन वाटर है उसका भी पाइप का वो कनेक्शन है वहां पे डाला होता है। दैट्स वाई क्या होता है, सीजनल वो इफेक्ट आता है। तो वो प्रैक्टिसेस जो है, जो ऑपरेशनल प्रैक्टिसेस को कैसे कम किया जाए, उसको कैसे बदला जाए, शायद उसके ऊपर हमें सोचना चाहिए। दैट्स वाई हम जो कम्युनिटी शॉक पिट बने हैं या कम्युनिटी के एक लेवल पे कोई ट्रीटमेंट बना है जिसको लॉन्ग टर्म तक सस्टेन कर पाए और उसको प्रॉपरली मेंटेन कर पाए। तो ये दो मेरे ऑब्जर्वेशन एंड थॉट्स थे।
Yes, sir. I think this is moreover an observation that you have said, and we also are habituated with a similar situation while we are going through the rural community. We also are seeing that, and most of the cases, this is a platform. This is a washing platform or dishwashing platform, or we can say a common washing platform for the household. They are preparing, and from there, the grey water is released, and there are different type of technology that has been adopted. In case of household, people are taking up of their own, but I think they are here right now. We should also have to, if we are taking up this soakpit lispit as one of the methodology of treatment grey water in a house in a particular community, then we should have to come up right now with the design thing and awareing the community on the design aspect, because we are seeing that there are challenges if we are not properly designing the soakpit lispit. And further, with respect to the waterlogging area, with respect to the terrain permeability, soil condition, so we should have to consider what should be the design criteria, design consider that people can take up. So I think awareness also is another thing that we should have to take up along with the campaign that we are taking up with respect to grey water management program. Thank you, sir, for sharing this. I think we also can consider area specific, location specific, what should be the solution that can be taken care of.
Yeah, good afternoon. Can I talk, please?
Yes, Dr. P.C. Ram, you can speak.
Yeah. Good afternoon, sir. And this is Dr. Shivaram. I'm one of the national WAS experts. And also, I worked with the National Institute of Rural Development and Panchayat Raj for a long time. And the questions, and first, I must congratulate both Ms. Amita and Purna for their wonderful presentation. That's coming to the questions. One is three types. Ms. Amita presented that three types of grey water management. One is decentralized, and second one is the semi-centralized, and third one is centralized. Okay. Regarding this one, anywhere have you WaterAid had implemented? If implemented, please tell the state, districts, and village names. And another is, what is the success rate there? Can you throw some light on that?
Yes, sir. So here I can share some of the specific locations that we have taken up grey water management on a holistic manner. Means we have taken up grey water management on a saturation approach in a community. It may not be the total village at a stress, but we have considered community, and accordingly we have tried to make saturations. We have taken up this series of villages nearer to Indore in Bhopal and also in Durg district in Chhattisgarh. We have tried to create some of the saturated villages with respect to grey water management. We have considered technology at household level, this leach pit and kitchen garden. We also have considered some technology at we are not telling centralized, we are telling even semi-centralized, because we have considered few households having 60-70 households, and all those waters calculated the volume of water, and accordingly we have designed the DWAT structure that will be appropriate to treat the water. And again we have considered what should be the reuse of the treated water. So there are examples, there are communities. Right now I may not share I may not share the names of the villages, communities, but these are all in those districts. We have created examples. Again, we are seeing that this also requires the continuous maintenance and continuous the lead. There should be a kind of leadership quality among the village community. They can share these. They can continue the campaign, and they can continue discussing with the community regarding the further challenges while they should have to take up the operation maintenance. And accordingly, till the time it would be a 3 to 5 years till the time they are managing the structures. So nowadays mostly people are utilizing the water at household level for kitchen garden, for plantation. Even there are community soak pits which are there constructed in case of community hand pumps, community toilets, and there are DWATs and DWATs as a community level structure at the semi-centralized structure. Yes, sir. Any questions for that?
Another one question I have, sir. Can I ask you or?
Yeah.
Somebody
Sure.
Yeah. And regarding the recharge of groundwater, you mentioned that, these are the recharge pits and all. Have you done any studies that really water recharging is happening? Okay, that's number one. And okay, and have you done any study on that? Have you done any study on that?
We have not done any studies, sir. We are now taking up the functional assessment of the semi-centralized structures that we have already implemented in last 2 consecutive years. So this year we are trying to take up some of them, and we are trying to functionality assessment of those structures, whether it is this thing. And regarding the recharge in case of household level also, there are let me tell you, we also have come through the similar challenges, that it is overflowing. So at some time of period the recharge rate is decreasing, so it is overflowing. In those cases they are going for, we have given the example, they are going for construction of second leach pit. Construction of a leach pit is connecting to the first leach pit, and in between they also have taken plantations, because if the water is coming out of the leach pit, that water they are managing in plantation. In some of the places we have tried to put these examples. Still there are challenges, and still we are overcoming with these challenges. So we are still in that implementation stage.
Okay, sir. Last I'll come now. Somebody will speak, I think. Okay. Thank you very much, sir.
Thank you.
Thank you,
Mr.
sir.
Shivaram.
Hello, sir.
Mr. Raghavendra sir is there?
Hello.
K. Raghavendra, please.
I think Raghavendra sir will be there.
I am there, sir.
Okay.
Raghavendra sir. I am
Yes.
Raghavendra,
Please
retired
ask your
chief
question.
engineer in urban water supply and both the rural water supply and drainage system, sir. So I am having one first question. I want to know from you. It is not a question. See, because you are working for a long time in this area. While presenting, just every time as in urban sector, you are provided that you are informed that 80% of water will come out as a grey water. I want to know anywhere you are taken up the studies for assessment of the grey water from the houses. if it is 80% or 60%, 21, because there in sewage system they will take out 80% because gray and black water will come to the drainage system. But here in this case, rural case, it is only gray water. How much percent? Any studies taken up, sir? First question, sir, please.
Sir, shall I answer to this?
Yes, sir. I am waiting for that, sir.
I'm sorry, sir. We have not taken up the study on this. We are telling the figure on a thumb rule basis that we are also means the same way we are sharing the thumb rule. In some cases, while we were going for designing the semi-centralized structures. We found the release of grey water while we are just collecting the information from 15, 20 households, 60 households to go for designing this. We have found that there is a difference of 65%, 70%, 75% of water that are coming as grey water, but those are all only we have taken up discussing with the people, and as a preliminary data, we have not taken any comprehensive study. We are sorry if any members who can share if they have taken up this study on this. We will, sir, definitely this is a good suggestion that you have taken. We will try to take up this study in future if possible.
Second point, sir. Second point. Thanks for your presentation. It is very good, very very well structured, and lot of inputs we got it. Thank you. When we go to the field, we got a lot of inputs. My second thing is, sir, a lot of inputs has given from your side in your presentation. Any technical assessment or analysis has been done for this? Your inputs, your thoughts, because for example, in only one point I will take. You are told that 1 meter wide of envelope will be sand envelope will be done. So whether it is 1 meter, 1.5 meter, or 0.3 centimeters, or whether you have been through any technical papers on this, sir. On what basis you have decided 1 meter, sir? That I wanted to know. That's all. It is not a question. I wanted to have an exposure to that.
So just this is not actually 1 meter, because generally wherever the soak pit, leach pit we are finding, the depth of the leach pit we are taking 1 meter, 3 rings as at a total, or it would be constructed of brickwork. So if the height is 1 meter, then we are taking at least 1 meter or more than a little more than that, 1.2 meter or 3 meter. We have indicated 1 meter there, but if there is a PPT, we have indicated 1 meter. But sometimes in the field, we are taking a little more than that. Means if it is indicated 1 meter, 1.2 meter. If the height is 5 meter, then we also have to take up the 5 meter. If the envelope is there, we are taking up 5 meter as a surrounding thing, and we are taking up that as a thing, so that if a vertical height is this having the water deposit, then we should have to provide a horizontal height so that water can leach in a proper process on a on its gradient, on its slope. So on that way we have provided. If we can get, if we also are expecting your advice on it, whether we should have to go in other way or not. As a scientist, also you also can share, sir, your thoughts.
Sir, for this, I am having my little exposure on this. I will tell you a lot of technical studies has been done at various technical institutes. They, depending upon the permeability, the thickness of that envelope has been come to some sort of a conclusion. I think a lot of institutes have done. So I feel that if you can share some value, for example, for this permeability, this much of thickness is there, or I'm not talking about the diameter of the soak pit or depth of the soak pit, the envelope outside, and deciding parameter. If you are not having this any information to be shared, it's also good, sir. Thank you, sir.
Sir, we will definitely. So it means, as told, we are taking on a thumb. If the depth of the pit is according to the depth, we are deciding the outside of the pit what should be the surrounding horizontal distance. But again, as you told, we will search for the documents from different institutes if it is up. And if it is there, sir, if you know if there is any documents, if you can share with us all, so it would be helpful that everybody can also have access to those documents along with us. If you are going through, if you are having some if you are getting through any material, please share us.
Okay, thank you, sir.
Sir,
Okay,
am I
thank you. Yeah, thank you, Mr. Raghavendra. Now we shall
Hello.
take the question of Kushal Amin. Amin, are you there? Kushal Amin? Kushal Amin, yeah.
Yes, sir. I'm from Jammu and Kashmir. Kashmir से हूँ sir मैं.
हाँ, बोलिए please.
Actually, now the people here, they have started constructing these leach pits by concrete rings, precast concrete rings.
जी sir.
How successful they will be? They are just putting earthwork को निकाल के सीधे उसमें रिंग डालते हैं. RCC के रिंग जो precast आते हैं, they are 4 डाया उनका होता है 2.5 feet to 3 feet. And depth varies और वो सीधा कंक्रीट डाल के पिट बनाते हैं. How successful with that?
सर, इसमें दो तीन चीज अभी राघवेंद्र सर शेयर कर रहे थे, आप उनका थॉट भी इसमें दो तीन चीज देखना है कि हाउ मच वॉल्यूम दैट इज गेटिंग इनटू दिस लीस्ट पिट और सोक पिट. We should have to, on a thumb rule, we should have to take 2 times the volume of water that is coming, so that easily the volume of water coming within a day can be leaching through the soil to the ground or to the subsurface level. So that is why on a thumb rule, and that has also been mentioned by Srikant Nabrekarji, कि we should have to take up 2 times more than the volume. But the recharging capacity depends on the soil type there. If it is permeable soil, then it can be all the water can be recharged within a shorter time, within 8 to 10 hours of a day, or even 6
तो मैं एक्सप्लेन करने के लिए
in similar way. So we'll have to consider the permeability of the soil and the volume of the water. If the permeability soil is okay, fine, and the volume, if we are taking up the volume as 2 times the volume of water that we are receiving for the least pit, then the structure is fine.
Okay,
Again,
so next question is we are talking about this one, this kitchen garden. Normally kitchen garden में हम directly पानी नहीं छोड़ सकते ना on daily basis. How that will work?
सर, इसमें दो चीज है किचन गार्डन में से. एक है कि उसमें से अगर ग्रीस ऑयल ये सब मटेरियल आता है, सो इट इज बेटर वी शुड हैव टू गो फॉर ए सिल्ट चैम्बर बिफोर वाटर इज गोइंग फॉर किचन गार्डन. एंड ये जो किचन गार्डन में जो पानी जा रहा है, इसमें अगर सॉलिड क्वांटिटी नहीं है, तो इसमें क्या हो रहा है ना, सॉलिड क्वांटिटी नहीं है तो ये डायरेक्टली वी कैन गो फॉर अप्लाइंग द वाटर फॉर किचन गार्डन. अगर कुछ भी सॉलिड क्वांटिटी है तो वी शुड हैव टू गो फॉर ए काइंड ऑफ कंटेनमेंट बिफोर दैट.
माय क्वेश्चन इज, हम डेली बेस पर नहीं डाल सकते ना, किचन गार्डन नॉर्मली छोटा ही होता है, तो हम डेली पानी नहीं डाल सकते ना उसमें.
तो फिर कंटेनमेंट, सर कंटेनमेंट करना जरूरी है. एंड वी वुड एडवाइज टू गो फॉर ए सिल्ट चैम्बर बिफोर द कंटेनमेंट, सो दैट वी कैन ट्रैप ऑल द ग्रीस ऑयल मटेरियल इन द सिल्ट चैम्बर.
कंटेनमेंट वो होता है ना.
सर उनका क्वेश्चन ये है कि रोज पानी डालेंगे तो पौधे हैं उनको पानी ज्यादा हो जाएगा, दैट्स व्हाई रोज तो पानी नहीं डाल सकते ना, वो सवाल है.
सो वही सर इसीलिए बोल रहे हैं कि इफ वी आर क्रिएटिंग ए कंटेनमेंट एंड फ्रॉम द कंटेनमेंट इफ वी आर अलाउइंग द वाटर थ्रू ए
कंटेनमेंट हैज टू बी ऑन हायर लेवल देन किचन गार्डन.
या
तभी वो जाके पर्पस सर्व करेगा.
सर अगर ग्रे वाटर ले रहे हैं, अगर फ्लो कर रहे हैं पाइप में, तो ये तो जितना ग्रे वाटर यूज करेंगे वो तो सारे जाएगा वहाँ पे. वी शुड हैव टू क्रिएट द डिवीजन ऑफ लैंड. यहाँ पे अभी पानी चाहिए, वहाँ पे और कभी पानी चाहिए, उसी हिसाब से वी कैन मेक ए डिवीजन ऑफ द लैंड अगर उसमें जा रहे हैं. आई थिंक ये सब जनरल सॉल्यूशन वी कैन फाइंड आउट, जो लोकल लेवल में भी हम लोग इसको करके वी कैन फाइंड आउट द सॉल्यूशंस. This is not anything related to the designing of the system. किचन गार्डन के लिए अगर सभी प्लांट में नहीं चाहिए, अल्टरनेटिवली चाहिए, so we should have to make the piping arrangement accordingly so that we alternatively water can reach to those places.
Okay, thank you. Now DE from DRW SEO, are you there?
Sir, good evening, sir.
Yes, yes. Please.
I am Chandrakiran from Andhra Pradesh, sir. Am I audible, sir?
जी सर, जी audible.
Sir, my simple question is regarding kitchen garden. Mainly the grey water from a house mainly consists of surface segments. So surface detergent water. So can you suggest me from your documentation that which type of plants, which type of vegetables can be grown based on your documentation? Can you suggest me, please?
Sir, generally kitchen garden is the nutrient garden which people are taking up at household level. But let me tell you, I am not having this knowledge, comprehensive knowledge on this. If any other can share, if anybody can share through chat or through email to SPM Nivas to us or to some other way, it can be accessible, then it would be better. I may not help providing a solution with respect to the type of plant that we should have to go for. Sorry, sir.
Purna sir, can I ask a question?
Yes, sir. Yes, sir. Sure, sir.
Yes, sir. Thank you, sir, for giving me again, opportunity to speak with you. And my question is regarding this, the soak pits. What is the rate of community acceptability? That's number one. Number two is, okay, if they have accepted, what is the rate of replication to other houses and all? Please, these two. Thank you so much.
Sir, I would say in the communities where we are working, people prefer to go for kitchen garden. Preliminarily, when we have started, people prefer to go for kitchen garden. And because this is a kind of awareness that is continuing also, people are going for soak pit, people are going for leach pit, because it is easy for them to get down the material without the filter media, the materials for filter media. So they are going for leach pit in most of the cases, because they are in the similar way they are constructing the leach pit for their toilets. So it is fine with them if they are considering leach pit for the construction. And in most cases also people are going for kitchen gardening, because that is a practice that they have already. So these leach pit and kitchen garden are the popular practice at household level. In case of the community having a drain, pakka drain outside or constructed by the panchayat, people used to allow the water to the drain. And that in that drain, we were also discussing previously in SPM Nivas also, in these type of constructions, we are having problem that storm water also is getting along with grey water in those drains. If you are going for treatment of grey water, we should have to think properly how we can take up this storm water and grey water combinedly in case of flowing the water in the drain. So this is a kind of thought that we should also have to provide a solution somewhere ahead. And acceptance is leach pit and kitchen garden at house.
Thank you, sir. Thank you so much.
Thank you, everyone. There is a good participation. Really very interesting session. Everybody has got some interest, and thank you for Mahanti Shah for explaining all the questions.
Sir.
Yes. Anybody there?
Yeah, I'm Ashish Biswas from Madhya Pradesh.
Acha, Ashish Kumar Vishwas, please ask a question.
Just thanks team Waterade. As always, new learning the team Waterade. Just I want to know what kind of precaution we should take in black soil area for the soak pit and leach pit.
Sir, we should not take the option leach pit soak pit for the black cotton soil because the permeability rate is very low. As we have already said, if you are still considering the option, then you can go for the creating a filtration gallery, creating a gallery of aggregate and putting plants like canna and some broadleaf plants of that category, which will act as a evapotranspiration model. Or otherwise, we should go for, in those cases, recharge rate is very less. So we should go for treating the water, and we also will have to think about how we can reuse the treated water. Otherwise, again, the treated water in a long run will also become untreated water if we let it flow on the floor, on the surface. So all these considerations we will have to make while we are treating those things. So if we can recharge that to the village pond or to some of the water body after treatment, that also can be another option. So we can think in that way.
Any demonstration units of Waterade?
We have taken up in small scale, not in large scale. This, as I have told you, this modified evapotranspiration model we have taken up in West Bengal, and we are now trying to treat the gray water that is draining to the village pond in some of the places in Chhattisgarh. But as I have said earlier, this year we are trying to make a functionality assessment of some semi-centralized structures that we have already created in place. So we are in a process of evaluating that. We may come up with the result findings or the learnings that we have on that in going ahead after this rainy season is over, and we can take up the study. We can share those findings and learnings of ours.
Thank you, sir.
We have already crossed our session. It is 5:40 now. I think now we can close the session with due permission from all participants and the presenter too. So thank you very much from SPR Nivas for such beautiful presentation. Very informative indeed, and a burning topic in India for certain areas where water logging is a problem. So thank you very much, and thank you very much to the participants also for hearing and for putting question. And if you have put some question in our Google form, we'll send us Google form to the presenter for the answer, and you'll get it. And if you want to view the recording of this session, you can go to SPM Nivas this YouTube channel. There you can find the live streaming of this presentation. So thank you once again. Anything from the side of Mr. Mahanti, please?
No, sir. Thank you very much giving us the opportunity. We will look forward such opportunity also going ahead. This is a session that we have taken up with respect to grey water in solution of grey water providing through leach pit and soak pit. There are many options also with respect to grey water, and there are also some diversity with respect to challenges, possibilities, solutions, and all these things. So we can keep up this discussion going ahead. And also we have received a very good suggestions, feedbacks through questions also. We have received very good feedbacks from our esteemed members who are present in the and we are thanking everybody who have participated in the workshop from Waterade India team. So thank you very much part of this. From Amita, me also, thank you very much.
Thank you, sir.
So thank you once again. We are going to close the session right now. Thank you.
sir.
Thank you.
Thank you, everyone.
Thank you so much to all of you.
And you, as you know, that we'll continue this webinar. Every week we used to hold 2 webinars, and we get very beautiful participants. And we'll definitely would like to meet you again in this platform. Thank you very much.
Yes, sir. Thank you.
Thank you very much, sir.